Hello everyone. My name is Oliver, and today I want to talk about the IRC formula, how it works, and its investigation. So first of all, I want to show you guys how the IRC formula looks like. From its name, we can know it's a formula to help us get the rate of change on a point on a specific point, and it looks like limit h approaches 0, f at a plus h minus f at a divided by h. So to help us understand the formula more clearly, I have drawn a graph here. It's arbitrary, so it can be any kinds of function, and we also need a point called point P, and it has an x value at A, and it also has a y value f at A. So because h is approaching 0, it's moving, so we need another point. Let's call it point Q. So point Q is on the left side of the point P, because we need to show I need to show you guys the preceding intervals before I introduce the whole formula for you. So the point P is on the left side of point P is on the right side of the point Q, which means h is a negative value. So the point Q, when h from the left side, let's set it as -2, and it approaches 0 from the left side, which from the negative side to 0, it becomes more and more closer to the point P. So I need to explain this red line is the tangent line on the point P, and this line connected point P and point Q is called secant line. So our work is to find out how, in what situation, the secant line become the same as the tangent line. So h approaches 0 from the left side, which means minus 0.4. It's like this. So you can see that it's a movement that make the secant line become closer and closer to the tangent line. And when h approaches at 0, it becomes minus 0.01. It becomes almost the same like the green line and the red line. The green line and the red line become the same almost. And when h approaches 0, it is the same line. Which means when h approaches 0, that the slope of the secant line becomes the same as the slope of the tangent line. So that means limit x approaches 0, f at a plus h minus f at a divided by h is working for the preceding intervals, so as the following intervals. And I need to point out is that it's a general situation, which means you can use this formula in any kinds of continuous function. But in some special situation, like the function is separate, like it has a gap between two parts or any parts of the function. Like I will show you this special situation. So The red line, the function on the left is its domain is x less than -2, and it has a hole at -2, 6. And here is a linear function, another function. Its domain is x greater or equals than -1. So in that situation, you can find out the IRC on this point because the preceding rate of change shows that it approaches to 6, but from the following intervals it approaches to like 4. It has no value for this point. So that's what IRC formula doesn't work. It can use for some like uncontinuous function, and that's what I talk about today. Thanks for watching.